Hello guys, welcome back to my channel Memo African Motives. Still working on the question paper of November 2018 for mathematics N2. So we shall have a continuation now on part 3, which is actually on question 3. So guys, if you're new to this channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So without wasting much of your time, let us quickly rush through the questions that we had on question 3. This is our question 3, and all in all it had 25 marks. As we can see here, we've got 25 marks. All right, so what do we have here on question 3? The question on 3.1 is algebraically solve. Take note guys, algebraically solve for x and y, which means you're supposed to use any method of solving the following equations, which are two equations that we are given, the first one and the second one here, which are simultaneous equations because you've got two equations there. So algebraically, which means you can use any of the methods, elimination, substitution, whatever method that you are capable of. It's not graphical because it can be algebraic or it can be a condition where you are applying graphically. So graphically you're supposed to use a graph, but this one algebraically. So what are you going to do guys? All right, let us quickly rewrite the equations. We've got 3x plus 2y in this case, which is equal to 6, and another equation which is 2y minus 4x minus 4, which is equal to 0, like that. All right, so these are the two equations that you're given guys. So what can we do? There are so many options that you can actually choose to use: elimination method or substitution method. All right, so using substitution method, because most of us, most of you guys, that is what you are used to. So I'm just going to use substitution method, or you can just apply elimination method still because it was the easiest. Okay, so it is easier for me to make y the subject because here, as you can see, these are factors of 2. We've got 2, 4 and 4. So let's just have our equation 1, our equation 2. So from equation 2, it's easier for me to make y the subject here because I'm just going to left with 2y is equal to, I transpose this to the other side, is going to be 4x. I transpose minus 4 to this side, is going to be plus 4. So that is going to be easier for me to divide by 2 by 2 by 2. It's easier for me if I do this way. So which means I'm going to be left with y is equal to 2 into 4, that's 4 divided by 2, which is 2x, 4 divided by 2, which is 2. So as you can see, we have formulated another equation. From equation 2, we now have our equation 3, with y being the subject of the formula. As you can see, it's easier for me. So I'm going to substitute this now into equation 1. So this is what you're going to do: equation 3 into equation 1, the part that you didn't work with. All right, so what I'm saying is that substitute equation 3 like this into equation 1. All right, into equation 1. So this is what you're going to do. This is our equation 3. In place of y here, we are going to substitute this part with 2x plus 2. So we are going to be left, take note, there is 3x, it's going to remain as it is. So 3x plus 2y, take note, this is 2y, which means 2 times y, like this. And your y in this case is 2x plus 2. So you're going to multiply this. In place of y, you're going to substitute 2x plus 2. So it's going to be like this. You open bracket 2x plus 2, like this. All right, then you equate to the number which is given on the other side, which is 6. So this is going to be equal to 6 as it was given. So guys, we can solve for x. In this case, that's going to be 3x, expand brackets. So in this case, we have to clear brackets, clear brackets. All right, so let's expand our brackets guys. That's 2 times 2x, 2 times 2, that's 4x, 2 and 2, that is going to be plus 4 is equal to 6. All right, So collect like terms. In this case, we can add these two. That's 3 plus 4. You add, because this is x and x, so you can add 3 and 4. So 3 plus 4, that is 7x. Okay, what about this plus 4? I'm going to transpose this plus 4 to the other side of the equation. So it's going to be minus 4. Take note, it was a plus. So it's going to be minus 4. So it's going to be equal to 6 minus 4, which is 2. All right, so what can I do to find x? Since 7 is multiplying x, I'm going to divide by 7 both sides. So my x is going to be 2 over 7. So therefore, that is the value of x in this case, which is 2 over 7. So since we are using substitution method, we have obtained the value of x. We are going to substitute back this value of x so that we can obtain the value of y. And what is the best equation to use? It is this one that we have made y to be the subject. So we are just going to substitute the value of x. Since y is equal to 2x plus 2 from equation 3, and our x in this case is 2 over 7 from this value that we obtained. So we are just going to substitute our x here, which is y is equal to 2 times x, which is 2 over 7, this value of x that you are given, plus 2, like this. So if you are maybe facing some challenges of applying or working this, you can just use your calculator. All right, let me just show you. Just use your calculator in this case. So this is going to look like this, guys. Let's just put our calculator here. There's too much light, guys, as you can see. So let's put it here like this. All right. So we have got this expression that is a 2 into, take note, guys, from our expression, that's 2 into 7. 2 over 7 plus 2. So you're going to open bracket there. Open bracket. Okay, already opened. So it's 2 over 7. Okay, move this aside. Close the bracket. All right. Then plus 2. Okay, so as you can see, we are going to obtain 18 over 7. That is 18 over 7 there. Okay, so which means from this substitution that we have made, we are going to obtain 18 over 7. I'm just showing you guys, but this one, you're just supposed to use your calculator, but I'm just showing you. Maybe if you have some challenges there, but that was the idea there. So your y is going to be 18 over 7. So therefore, we can conclude these two to say, therefore, our x is and y is equal to 18 over 7, just like what we obtained in this case. So these are the two possible, these are the values that we obtained, the value of x and the value of y, by using a substitution method. So like I said, you can use any method of your choice, guys, which is the best. Okay, determine the dimensions of a rectangle if its perimeter is 98 meters and its length is 3 meters longer than its width. Take note, guys, the length is 3 meters longer than its width. All right, let's just have this, maybe just try and have a presentation of a rectangle, right, like this. All right, so this is your rectangle. You know, this is your length and this is your width. All right, which is the breadth. So the perimeter, remember, perimeter is distance right round. Let's not focus about this. Let's start with this part where we are given that the length is 3 meters longer. So how are we going to relate the length and the width? If the width is given as w like this, and this length is 3 meters longer, it means the length is equal to the width plus 3. That is 3 meters longer. You're going to add 3. If the width is 5 like this, the length is going to be plus 3, which is going to be 8. If this is 6, you add 3. So if this is w, you're going to add 3 like that. All right, so guys, take note. So guys, remember the properties of a rectangle, that these sides are opposite and equal. So this is w, and this is our length in terms of w, is w plus 3, where w is representing what? The width. So this is your rectangle, and you are given that the perimeter, which is the distance right round the shape, is 98 meters, like this. All right. So the question is, what is the question? Determine the dimensions of the rectangle, which means the dimensions, we are calculating the width, which is our w in this case, and the length, which is our L. So these are the dimensions that we need to calculate. But as we have written this in terms of W, which means we are going to calculate W first, you can write this in terms of L, whatever that you want. So you are going to formulate an equation now, because you know that the perimeter of a rectangle, take note that this is the perimeter of a rectangle, guys, is 2 length plus 2 width, like this, or 2 into length plus width, just close a bracket, so on, and the same thing. So if this is the case that we are talking about, which is the same as this one, therefore our perimeter, which is 98, is going to be equal to 2 times the length. So it's 2 times the length, which we have written in terms of W, which is W plus 3. So that means we're going to substitute our W plus 3 like this, plus 2 times the width. Already the width is the width as it is, so it's just going to remain as it is. What we need to write is our L in terms of W, and our L in terms of W is W plus 3. So we have formulated an equation, guys, that we can solve here. So let's just solve this equation. 98 is equal to 2 times W, that's 2W, plus 2 times 3, which is 6. This part is not part of the bracket, so you're just going to write as it is, which is 2W, like that. All right, let's collect like terms, guys. Plus 6 to this side is going to be a negative, so it means you're going to be left with 98 minus 6, and this is going to give you 92, guys, from your calculator, which is going to be 2W and 2W. These are the ones which are left, so 2 plus 2, which is going to give us 4W, like that. And remember, what you want to calculate is the value of W, so definitely we have to divide by 4 like this. All right, so therefore our W is going to, if you divide these two, you are going to obtain 23. Yeah, that is what you're going to obtain in this case. So I hope it's clear. Let me just try and adjust this side here. So in order for you to calculate the length now, since the W, which is the width, is there, we can just substitute here, because our length is equal to W plus 3. Remember that. And your W in this case is 23, so which means your length is going to be 23 plus 3. You substitute in place of W the value of W, which is 23. So adding this, you're going to obtain 26, which is meters. So this is your length, and this is your width. As you can see, the question was asked to calculate the dimensions. So you're supposed to indicate now your dimensions, not just to calculate the value of W, no. The dimensions is the width and the length. So take note, guys, when you're answering this question, it's not enough just to find the value of W and leave it like that. No. All right, so let's see another question that we had, which is the second end of a clock takes 30 seconds to move through an arc of 180 degrees. What is the angular velocity? All right, the first thing that we are given is the time that was taken, which is 30 seconds, and the angle, which is 30 degrees, which is 180 degrees. All right, when you are referring to the angular velocity, this part here, we know that it's a relationship that we have, that we can relate. Let me just write the formula 3.3 here. We know that our angular velocity omega is actually the displacement over time, which is this just the angular displacement, just your theta, which is measured in what? Which is measured in radians. All right, and this time is in seconds. This is what you're supposed to have. But let's see, this is 180 degrees. This one is in seconds, is fine. But what about this 180 degrees that we are having? We are supposed to convert this to radians first so that we can apply this formula that we are given. So let's do the conversion here. Remember, in order for you to obtain theta in radians, you are going to use theta in degrees over 57,3. Your theta is now in radians. All right, so which means your theta to be in radians, this is the concept. All right, so which means our theta is going to be our theta in degrees, which is 180 degrees that we are given here. So it's 180 degrees over 57,3. All right, so there I want you to use the calculator. You're going to obtain something like 3,14 something, which is going to be just 141 if we round it off. So this is now in radians. All right, so this is our theta in radians. So now we can apply our formula here, that the angular velocity is theta, which is in radians 3,141 over the time, which is measured in seconds, and the time we have this time in seconds, which is 30 seconds. All right, so you can divide by 30 there, which means you are going to obtain 0,105. Just divide using your calculator there, and we know that angular velocity, which is measured in rad per second, remember you are dividing rad over seconds, so it's going to be rad per second. So that is your angular velocity in this case. All right, express 0,5 rad per second in revolutions per minute. In revolutions per minute. So how do we have this conversion, guys, in revolutions per minute? Take note. All right, let me write this down here. I want you to have this relationship down. If we are given 0,1, this is 3.4, 0,0105 like this. This is rad per second, and our answer should be rad per minute. Okay, so you just ask yourself the relationship between this a second and a minute. All right, the relationship is in a second, in a minute actually, that's where we can take our relationship. We have got 60 seconds, that is what we have. So if we have 60 seconds, that is in revs per in a second, this one, which means we can just multiply to convert per minute. So this is going to be rad per minute. All right, so we can just multiply, because in a minute we have got 60 seconds, so we are going to have 0,105 rad per second times 60 seconds, which is going to give us something like let's just maybe do this together, it's going to be fine. Still 0,105 times 60 like this. All right, so you're going to obtain 6,3, which is now in rad per minute. All right, it's now easier for us to convert to revs, because these are revolutions per minute. It's now easier for us to convert in revs per minute, because this is already in rad per second. All right, take note that the relationship between rad per second, which is the angular velocity, and revs per minute, which is the speed n, is that you can even take this in your formula sheet. It's W, which is angular velocity, is 2 pi n. If this is in revs per second, in rad per second, this is going to be in revs per second. If this is in rad per minute like this one is going to be in revs per minute. So already this is in rad per minute. So to find n, just divide by 2 pi by 2 pi because we need revs per minute. So this is gonna cancel. Your n, which is the speed in revs per minute, is going to be the angular velocity over 2 pi, which is the angular velocity in rad per minute, which is 6,3. So it's going to be 6,3 over 2 pi. All right. So I want you to use your calculator to divide these two values. You are going to obtain a decimal like this, guys. 1,00226, something like that. So if you round off, it's going to be 3. So you are going to obtain 1,003. Take note that there's a 6, so this 6 is going to round off this to 3. This is now in revs per minute. Remember, we want our answer in revs per minute. So that was the idea there. So there are so many concepts that you can use. You can choose to just convert to revs per second, then you multiply by 60, which is either way you're going to obtain the same thing or the exact answer, which is the one that we obtained there. On 3,5 we are now given that the arc length of a sector is 3 meters and it subtends an angle of 10 rad. Calculate the radius. All right, so this information is enough for us to calculate the radius. Why? Because we are given the arc length, which is s. So you remember, arc length can be written as s, which is 33 meters in this case. All right, and the angle which it subtends is 10 rad. So theta is equal to 10 rad like this. All right, so this is 3.51. all right. So from this information, how can we calculate the radius? All right, we know the relationship. This one, you can even take it from your formula sheet in a case that you have forgotten this. S is equal to r theta, which is the arc length. So this one is going to be given as arc length. So arc length is equal to the radius times theta, or it can be given, this formula can be given like this. It can be theta is equal to arc length like this over r like that, which is the radius. So making arc length the subject, which is s, you're going to have this. So in this case, we want to calculate the radius. So take note, the arc length is supposed to be in meters and this will be in radians. So to find the radius, simply divide by theta. So your radius is going to be s, which is the arc length over theta. So your arc length in this case is 3 meters. So it's going to be 3 over 10, which is your theta in radians, because this one is already in radians. So 3 over 10 from your calculator is going to give you 0,3. The arc length was in meters, so definitely, guys, your radius is going to be in meters, because the arc length was in meters. So there's no way we can have this in another unit. It's going to be also in meters. So that is what we had, and the other part is now to calculate the area of the sector. So as you can see there, we've got the area of the sector. So how do you calculate the area of the sector? All you need is the formula. Remember, the area of the sector is given by the formula half r squared theta. That is the area of a sector, where r is the radius in meters, theta is an angle which is measured in radians. So that means our area is going to be half times r squared, which is this radius that we obtained here. So it's going to be 0,3 squared times the theta, which is the angle in radians. So you multiply by 10. All right. So that was the concept there. So multiplying by 10, we are going to obtain something like 0,45. And this is the area, guys, which is measured definitely in square units. and in this case we are talking about meters, so it's going to be square meters. So that was the concept for this one. Then let's say the 3.6. On 3.6 we are given that a solid cylinder has a base diameter. Take note, you are given the diameter in millimeters and the perpendicular height of 25 millimeters. Calculate the surface area of the cylinder. Okay, so if you forget these formulas, they are going to give you all these formulas. The cylinder, I've got the volume, the surface area, and so forth. So as you can see, the surface area is 2 pi r squared plus 2 pi r h. All right. So what you need is to have the information. We are given the diameter and the perpendicular height. All right. So which means according to this cylinder, we need the radius, because this is diameter. So the radius, remember, radius is diameter over 2. That's diameter over 2. That's your radius, half of a diameter. So your diameter is 10. So it's going to be 10 over 2, which is 5 millimeters. And the perpendicular height is the one that you're given. So the height here, which is actually the length, is 25 millimeters. So this is 25 millimeters. Remember, guys, a cylinder like this, that's your cylinder. All right. So this is your perpendicular height, which is length. So you can just write as h. Okay, it's fine, like h. And this is your radius. All right, so you can have it like that. So the question is, calculate the surface area of what? Of the cylinder. All right, so where are we going to have our surface area? Remember, I talked about this formula of finding the surface area. So you can just substitute into the formula there. The surface area in this case is equivalent, that formula, pi r squared is 2 pi r squared plus 2 pi r h. This is your surface area. Just substitute the formula as it is. Now let's substitute, guys, the information that you're given, because here we have got 2 pi r squared, which is the radius. Our radius is 5 millimeters squared, plus 2 pi r, which is the radius, which is 5, times the height, which is the height of 25 millimeters. So it's a matter of substituting. So here you can put bracket or you can just multiply. So you can just use your calculator, guys. At once you're going to obtain this decimal, then round it off. You have something like 942,495. So this is going to remain as 495. And this is the surface area. You are referring to area, guys. And area is all about square units. So this means, since we are working with millimeters, this is going to be square millimeters. So area, whenever you are working with area, it's square units. So that is the concept. That was the concept for this question, actually. That is what you're supposed to do. Then what is the maximum volume now? 3.62. Calculate the maximum volume of the cylinder. All right. Still on our formula sheet, the formula for volume is there, which is pi r squared h. So we're just going to substitute into the formula because it's a cylinder. So this is what you're going to have here. So we said this is 3.62 and we need the volume of a cylinder, which is pi r squared h. All right, so you just substitute again, just like what we did in the previous part. The radius is there, the height is there. So it's going to be pi times r squared, which is 5 squared, or you can just put a bracket there, times h. Your h in this case is 25. So you're going to multiply by 25 in this case. So you obtain another decimal, just like the previous part. Just round off to 3 decimal places. You're going to have something like 1963,495. Yeah, and this is volume, guys, which is cubic units. So it's going to be cubic millimeters. So that is the volume. Take note, guys, we are working with millimeters here. We are working with the millimeters, so it's going to be cubic millimeters, not cubic meters, but cubic millimeters. All right. Then the last question is, the cylinder is melted and recast as a square. Calculate the dimensions of the square. All right, which type of a square are we talking about here? Because if you take this cylinder, which is a solid, and you recast into a square, what type of a solid is going to be formed from a square? Take note, a square is going to form a cube because all the sides are equal, so it's going to be to form a cube, which is a rectangular prism, something like this. So it's going to be, this is what is going to be formed, which is a rectangular prism, like that. But since this is in form of a square, it means the sides are all equal. So the volume of this is going to be side to the exponent of 3, which is the volume of a cube. From the surface area of a square, this is what you're going to have as your formula for a cube. Take note, this is a cube, not a normal prism. All the sides are equal in this case. Okay. So now what is the condition of melting a cylinder? Then we recast as a cube. These two, this when melted, it is not going to change its volume. So which means it is going to possess the same volume as a square, which is as a cube, which is this rectangular prism, but it's a special rectangular prism that you're talking about. So we are going to have this relationship. Let me write it down. The volume, this is 3.63. So the volume of a cylinder in this case is actually going to be equal to the volume of the cube which is formed. This is not a square. It is going to form a rectangular prism, which is a cube. That's the special name. So if the volumes are the same and we want to calculate the dimensions, we are going to say the volume of the cylinder that we obtained, which is 1963,495 in this case, is equal to the volume of the cube, which we said the volume of a cube is given by this formula here that I wrote here. The volume of a cube is side to the exponent of 3. So that means we are going to have side to the exponent of 3 for the volume of a cube and equate it to the volume that we are given, which is 495. So what is going to be the side? Because we want to calculate the side. The question is to calculate the side, which is the dimension. So definitely to remove these 3, you introduce the cube root. You introduce the cube root on both sides. So that means these 2 definitely will cancel each other. These 2 will cancel each other. So therefore, S, which is the side of the cube, which is the side of the square part that you are given, which is a rectangular prism, which is a square prism, is going to be the cube root of this side because all the sides are equal. So you're going to obtain in decimal, then just round it off. You're going to, is this 12, not 15? This is 12,52. Yeah, to 3 decimal places. Yes, let's just put to 3 decimal places, which is going to be 22. And this is in millimeters. Remember, guys, our dimensions were actually given in millimeters. So this is going to be millimeters. So the side. So this is the side, which is the length of, because the sides are equal. So the volume is side to the exponent of 3. So this side is the length. So this S, I'm referring to it as a side, the side of each part of a rectangular part that you're going to have, which is a square. That is the dimensions. So this part, they are equal, they are the same. So each is going to give us the same value of 3,2. So take note, guys, the dimensions are in millimeters. So everything here is supposed to be having millimeters, not meters. All right, so that's what we had, guys, from this question 3 that we had. So like I said, we are going to be working on these questions differently. So we shall meet again working now on question 4 so that we can see how we're supposed to answer that question 4. But for now, that's what we are having, guys, for Mason African motifs till we meet again.